We don't want to drill all the way through here accidentally. Keep track of the depth. So we're going to come up close to the notch, but certainly not all the way. Just give it a quick little zippity-doo-dah here. So, we're cutting this little relief in the bottom, this little step, so it has two bearing pads underneath it. Make sure I've got it going the right way. And it's pretty, I would say, uneventful, but oops. The only thing of note here is that it has a 30-degree angle that blends to this surface here. And we're going to use a little D-bit cutter. You can set it up at an angle like that too, and mill that. You can do it that way, but I'm going to use a little D-bit cutter because I found one that has the right angle on it. So, all right, pay attention here. Double check my, yeah, that's good. So this one is 55 thousandths deep. I'm just going to go about 40 to start with. Okay. And let's get close to where I'm supposed to be. So this is one of those Niagara stabilizers that my friend Dennis Nolan gave me. These things are pretty awesome. I've been using this one for quite a while actually, and it's just hanging in there. I'm paying attention to my numbers here. So let's go down to 50, and we'll leave a little bit for a finish cut. And I want to use a little bit of oil, and it gets a nice finish on it when you do that. Give it some liquid love. And then go to my numbers. So what we got here, bring that down so you can see it. This is a, we call it a D-bit cutter, or I don't know. It's a single flute cutter that you make on the decal or a D-bit grinder. And you split around tool in half, around shank in half, and then you grind a profile, a desired profile in there. And they're really handy because you can put oddball angles, oddball radius, you can make full radii, custom sized ball end mills. So they're used a lot in the mold and tool and die industry for stuff like this. Now we're gonna put this, this little 30-degree lead in on that edge. And what I wanna do is I don't wanna drag across the bottom, so I'm going to touch off on the bottom and just zero my my quill readout, and then I'm going to come up like a thou, okay? Just so I leave a nice scratch like that in there. All right, I guess I didn't get a good. Well, I guess I'll be grinding that surface, huh? Well, I was going to grind it anyway, but. All right, so come up, for whatever reason, I didn't get a good zero there, okay? And we'll just do one side here and go to town. Now, you can't hog material with these single flute cutters. And you know, they only have one effective flute, and you got to feed them real slow to get a nice finish because they're slapping away like a fly cutter bit, right? And but you can their advantage in a case like this is you can get any profile you want. And like I said before, you can stand this up and do it with a regular end mill too. I'm just doing it this way because I can. All right, so I'm catching the edge now. Take a few passes. So now you can see the angle there that's going on there. And what we're looking for is we're just looking for a good blend in those intersections. In this case, it's just a decorative little thing. Pretty good right now. Blow that off and get a look at it. Okay. Yeah, I'm going to stop there. And then, you know, you can check it with something that's got an edge, right? And see if it catches, and it doesn't here. Let's go over here. I kind of know what my number is in case you're wondering. I don't have to eyeball it every time. Yeah, I'm getting close now. Definitely get a better finish that way. Go to my number and feed real slow. Get a nice finish. And Bob's your uncle. Yep. Just whip. It's just like a slide there. Nothing catches. You don't feel anything. Okay. All right, so we're going to smack some chamfers on here on these corners, And we just have a 4-flute 90-degree chamfer mill in there. And what I like to do on chamfers is I use a fence, I guess I call it a fence or just a reference edge, for all the edges, right? So in this case, it's the back jaw of the vise there. So we'll make a cut, and then we'll close the vise, and then we'll cut the long edges. But I'm always referencing this fence, so the height of the tool and the position in relation to this edge is what's important. And I just keep going to the same numbers as opposed to trying to work it out and match it on each edge. Now this is manual work, okay? CNC, it's like, you know, it's a trivial thing to drive around that and do that, okay? But what you want is you want these to match up real nice and so they look good, because if they don't, they stand out pretty badly, okay? So let's just go ahead and we'll do a couple here. I'm not gonna torture you with watching all of them here. And I've already, you know, I did one, so I don't have to fish around and do the numbers. Okay, so I'm going to back off. Oops, I'll back off some amount that makes sense for leaving for a finish cut, right? And then once again with chamfer tools, you want to feed them slowly, just so you get a nice smooth finish on them. If you feed them too fast, they'll look notchy, and you'll have to do some handwork and whatnot. Okay, so there's one. All right. Okay, and then we'll flip it around and do this edge since the vise is already open to that dimension. Sure, down all the way and back off a little bit. Make sure I'm backed on. Now this is just a roughing pass, so I can feed that faster by hand. I'm taking a fair amount off. And I'll feed back by hand. So the main point is that, yeah, we're using that single edge as our reference. That's the main thing, okay? Let's get a little tap. Be sure we back off. I got 4 of these parts to do. They have a little groove going through them. These are the verticals that the V-blocks run up and down in. And I kind of want to do them all together, you know, run the slot all at once. This saves work. But some of you may have experienced when you put some parts in, you gotta open the vise up Mr. Buckaroo. If there's any kind of minute variation in the parts, width-wise, you don't get equal clamping necessarily on the part, right? So this is always a danger when you're doing this kind of work. So there's a couple ways you can handle that. One is you can use a little bit of paper. You know, you can cut a little strip of paper and put it in there, and then that helps take up any of the anomalies between the parts. Now they should be pretty close, okay, but there's no guarantee that they're exact, right? And you don't want to find out the hard way, right? My preferred method in this case is I use a piece of, this is aluminum welding rod here, you know, TIG welding rod. This is 4043, I think, nice soft stuff. And what I like to do is, those are slightly magnetic or something there. Oh, I see what's going on. I got the rubber band on the, okay, well, now what? Let's regroup there. The parallel is, they're moving out of the way because I got the rubber band on it, right? So let's try that again. Bring this up close, like so. Okay. And then what I'll do, now I don't have the rubber band on it, so the parallel will stay there now, okay? So what I'm going to do is I'm going to put this between the vise jaw and the part here, nice and high, okay? And then what I'm going to do is clamp that, and what that does is it compresses this and flattens this aluminum welding rod and takes up for those anomalies. And I'm going to smack this down a little bit too. And since it's round, you know, it's a point-and-point contact, so it deforms a little bit real nicely. So it finds a good equilibrium, I guess is what I'm trying to say there, in a lot more words. Okay, so now this is a pretty safe and secure setup here, and I still have a good datum reference against this side to do the milling. Anyway, that's what we're going to do without the rubber band. So get 0. Now this is an anti-bozo move because I know myself pretty well. I got this rod sticking out here, and I just cut it off with a pair of cutters. So it's just waiting to stab me or scratch me or gouge me or poke my eye out or something horrid, right? Okay, that's better. I put it this way, it won't quite hurt as much. All right, so let's take a 50,000ths cut, see what that looks like. Pretty friendly. Chips look good. This is one of those Niagara stabilizers again. I'm going to increase the feed rate a little bit. Okay, the chips change color a little bit when I increase the feed rate. At least I think they did. So we're going to machine the width of this slot less than the width of the V-block. That way we can grind that those sidewalls so they're nice and straight and smooth and all that nice stuff. So, all right, let's turn out another 50. See, those end melts just cooperate. They're just amazing. That's zipping along pretty good too. Let's take a little measurement and see where we're at. So to do that, what we're going to use is, I always like to measure this kind of stuff with an adjustable parallel, because it really, you know, you can wedge it in there nice and tight, and you're pretty comfortable. You got good contact in there, and then you just measure over the top of that with a micrometer here. All right, 485. 485. Okay. All right, pretty good. I think I'm going to go a little bigger than that. And the question is, how much do I want to leave there?
So we'll grind, we're gonna grind this first when we grind, after these are hardened. We'll grind this first so that they're all cleaned up and nice and basically to nominal. The pieces that slide in here are over thickness, but getting the thickness to match this is easier than getting the width to match the thickness. I hope that makes sense. Anyway, that's what we're gonna do. Let's see. I'm just moving over to, I should have done this from the beginning, but I forgot. But at least I remembered. All right. So, pin down. Back through them. It's better if you do this first, but I forgot. This is anchor lube here. Let's see. Cheese. So one characteristic of A2 that's a little interesting, I always think, hold on a sec, right there, okay, is when you use these spiral flute taps, the material's not real ductile, so it tends to break up into little chips and stick to the tap. So you can kind of get away with power tapping pretty deep, I guess, is part of it. The chips break up into small pieces, which is just an observation of mine that I've noticed. It doesn't make a curly, stringy chip, you know, like you would in mild steel or stainless or something like that. So here's the setup for putting this little angle on the vertical guides here. And I'm using, this is actually an interesting little sign bar I got off eBay. I was going to do a restoration on this one, and it's nicely made, and it's actually pretty accurate. I checked the roll centers, and they were pretty good. It's got a little bit of corrosion on it, so it needs a little rehab, but it still functions fine for this kind of application. The reason I use this one was it has a little stopper on it, and it's a little less than 1/2 inch, which fits this groove here, and so we get a kind of instant stopper out of it. Anyway, this happened to be kind of right for the job here, and so I was all excited. This is typical of me, right? I was all excited I could use this tool, and I was fiddling around with it, and I chased all the threads so I could move the stopper around and did all that, and then I went ahead and milled one, right? Then I went, oh wow, that came out great, and then I realized, oh, you dope, I forgot to do the and you know, this is the danger, right? There's a little grinding relief that goes in these corners here, right? And it's actually a hell of a lot easier to put in when the thing is orthogonal like this and not angled. Now, it's not the end of the world. I realized it, and I went, all right, what do I do? And I went and looked, and I got a way to hold this that's not too bad. That'll be kind of fun too, to put those little corner reliefs in there for the grinding. So we're going to proceed with this operation here, okay? And you see how it goes up against the stop there, real nice. And then we get a nice amount of clamping still. Just going to push down a little bit on that. Snag it down, okay? And we're using this big roughing end mill here, although it leaves a nice finish on the bottom that won't take much to grind off after the fact, okay? So let's go ahead and do that. Okay, and I got there's a little witness mark there, hard to see, you'll be able to see it on that one. Just a, you know, it's a kind of a oh hell deal there. All right, let's go down within about 5. I'm just going to put a little liquid love on there. Drop it down the rest of the way. And speed it up a little for the finish pass. Feed nice and slow. I don't leave a bunch of lines in it because this cutter's moving pretty slow, so